operating system. In today's session, we are going to continue with the topic Introduction to Operating System. Myself Kunal Panchal, your instructor. In this particular session, we are going to discuss the remaining operating system, which is nothing but a distributed operating system. Second one is parallel operating system, and third one is real-time operating system. So in previous session, we have already understood and we have started our journey of evolution of operating system with batch operating system. Then we have discussed spooling, then multi-programming, then multitasking, and now we are going to discuss the advanced operating system, which is nothing but distributed, parallel and real-time operating system. Okay, so let us discuss each one in detail. So the first one is distributed operating system. So when we are talking about distributed systems, or we say distributed computing system, so one thing you have to keep in your mind: without network, distributed systems you cannot imagine. So means without having a network, you cannot imagine distributed system. Okay. So first of all, we need to understand what distributed system is, and then we'll discuss its application and its pros and cons. So let us discuss what is distributed operating system. So to understand the distributed operating system, we need to concentrate on this particular figure that you can see in this particular slide, in which we have different CPUs, or you can say processors. So what is distributed system? So a distributed system consists of multiple CPUs, and multiple CPUs are, or you say multiple processors are interconnected with the help of communication network, and each CPU or say processor has its own local memory and its peripherals. And if any CPU wants to communicate with another, or we can say if any processor wants to communicate with another processor, in the case of distributed system, that can be possible with the help of message passing system. So the processor has its own local memory, or we can say local resources are called its local resources, and if processor uses the another processor's resources, in that case that resources would be considered as remote resources. Fine. So this CPU, each CPU has its own local memory. So it means what? In the case of distributed system, the CPUs or the systems are independent in nature. They are not dependent with each other. So that is the reason why it is also called as loosely coupled system. Loosely coupled system. Why it is called loosely coupled? Because each and every processor has its own local memory and other peripherals. So that's why they are independent in nature. So that is the reason why it is called loosely coupled system. And if any processor wants to communicate with another over the network, that is possible with the help of message passing system. So this is all about the working of distributed operating system, or you can say understanding of distributed operating system. Now, based on this understanding, you need to keep these things in your mind. First of all, we are going to discuss the various examples of distributed, or say applications of distributed system. So you can see telephone networks and cellular networks are nothing but example of distributed systems. Fine. Computer networks such as internet is nothing but example of distributed system, because nowadays everything is distributed. Yes, like banking system is nothing but a distributed in nature. Okay, ATM machine uses distributed operating system. Fine. Mobile computing, in that case means all these different examples in which we are using distributed operating system. Okay, there are many more applications we have, but in this particular slide I have shown some of the popular applications of distributed operating system. Okay, before going to discuss the advantages and disadvantages of distributed operating system, this distributed system can be designed into two ways that we need to discuss. Means what? There are two types of distributed system. First one is client server system and second one is peer-to-peer system. So what these two types of distributed systems we have, and what it means actually, that we are going to discuss in next slide. Okay, so means this, what it means actually, distributed system can be implemented or can be designed in two different ways. One is client server model or you can say system, and second one is what? Peer-to-peer system. So let us discuss each one in detail. Then we will discuss finally the pros and cons of distributed system. Okay. So what is client server system? You can see the architecture of client server system, in which there are various clients. You can see there are various clients are there, and one server we have, and all the clients are connected with the same network, and on the same network we have installed one server. Okay, so in this case what will happen? Again, these clients are diskful clients, we can say. Means what? Each client has its own processor and its own local memory and other peripherals. So these clients are not dependent on each other. So that's why we can say that it is one type of we can say distributed system, in which it uses client server paradigm. So what will happen in this case? When any client wants to perform, or if any client wants to execute a particular task, so that client will request to the server to perform that task and get back the result to the client. So what will happen if any client is requested? Say for example, if client wants current date and time, so this is the request of the particular client, and that requested would be forwarded to the server. And what server will do? Server will process that request and give the response as a result to that particular client. So in this way the client server system works. But what are the advantages and disadvantages of this type of system? If we are going to implement such type of paradigm, so what are the pros and cons of such type of system? So main disadvantage of such type of system is what? Single point of failure. Means there is only one server. If that server goes down, everything will be goes down. Means what? Whole network will be disturbed. Means if client sending a request but nobody is able to receive that request and process that request, so definitely nothing will happen. So there is a single point of failure, because we do not have any other replica of the server which can handle the client request. Fine. So if server goes down, everything will be lost. Okay. What are the advantages of such type of system? The main advantage is what? Security. It is more secure. Why? Because, and it is easy to implement security mechanism in such type of paradigm. Why? Because in this case we need to protect one server only. Okay, irrespective of the client request, we need to protect the server, because server is handling all the tasks. So it means, because this type of system is nothing but centralized system. Everything is managed by the server. Everything is processed by the server. Fine. So we need to protect, or we need to secure a mechanism on this server only. Fine. So we need to implement a security mechanism on the server only. So definitely, if everything is managed by the server, the coordination or you can say execution is easier as compared to peer-to-peer systems, or you can say peer-to-peer paradigm that we are going to discuss in next slide. Fine. So these are the pros and cons and understanding of client-server system. Now second one is peer-to-peer system. So what is peer-to-peer system? So in this case you can see in the figure there is no concept of client and server. Okay, means all the nodes or systems in this particular network will have the equal privileges. Means everybody can request the task to execute certain things, and everybody can process the task also. Fine. So there is no client, there is no server. All the systems have equal privileges. So just like a mesh network, you can see a mesh topology we have already understood in the basic understanding of network. So this is nothing but a mesh structure, we can say. So in this case, what will happen? What are the advantages and disadvantages of such type of paradigm? Definitely, it is very complex structure to implement, and it is somewhat costlier as well, because in this case cablings are required, and all the machines should have the equal privileges. So definitely the resources requirement would be higher, and it is very complex to design. As far as one parameter we are talking about security, it is very difficult to implement security mechanism in this case. Why? Because we need to secure each and every node in a network instead of a single node that we have discussed in the client server system. So definitely to implement security mechanism on each and every node is somewhat difficult, and it is very complex to design as well, because large number of cablings are required. Fine. So this is all about peer-to-peer system. Definitely the resource sharing is higher in this case. So definitely reliability would be there in terms of failure. Suppose if any node is failed, definitely we can get the data. If data is replicated among the various nodes, if any of the node is failed, so we can get that data or recover that data from the another node in a network. So reliability point of view, it is good, but it is costlier approach. Fine, and it is very complex to design. Okay, so this is all about peer-to-peer system. So in distributed system, what we have understood the concept of distributed system, what actually it means. Then we have discussed the applications of distributed system, where it is applicable, and we have discussed there are two ways through which we can design the distributed system. One is client server paradigm, and second one is peer-to-peer paradigm. Okay, now we are going to discuss the overall advantages and disadvantages of distributed system. So when we are talking about advantages, definitely we are doing resource sharing. Resource sharing is resources can have of two types. One is it can be a software resource, or it can be a hardware resource. Like say for example, if you are sharing a printer in among the various nodes in a network, so definitely it is cost effective approach. Fine. So this is one of the advantage, resource sharing. Second one is performance would be improved, throughput would be improved. Fine. Then high performance ratio would be there in this case. Higher reliability, as I told you earlier, if any of the node is failed, we can recover the data from the another node in the network. Fine. So these are the advantages of distributed system. Now what are the disadvantages? One more advantage is what? Scalability. Means what? You can expand this network for in large geographical area. There is no limit, because in this case the bandwidth is not shared. Fine. Each and every node has its own resources. Okay, so the bandwidth is not shared, as we are going to discuss in a parallel system, in which the bandwidth, one shared memory concept we need to use in that case, that we are going to discuss in upcoming slide. But these things to keep in your mind. What are the disadvantages? Definitely it is somewhat complex to design. It is very complex for implementation purpose. Fine. So these are the advantages and disadvantages of distributed system. Now the next one is the parallel system. What is parallel system? So in this case, you can see in this particular figure, and you can compare this figure with the figure of distributed system, in which in this case all the CPUs or processors are interconnected through a network. But in this case, there is no concept of local memory. Means each and every processor do not have its own local memory in this case. So in this case, the processors are interconnected with each other through a computer communication network, but they are sharing one system-wide shared memory concept. Means what? In this case, they are using the concept of shared memory approach for communication purpose, for reading something or writing something or storing something. They are using a common memory area. All the processors are using this system-wide shared memory area to read something or to write something, anything from the memory. Fine. So what will happen in this case? In this case, definitely processors are dependent with each other. Why? Because if one of the processor is doing a particular task, say for example, if one processor is writing on a particular variable, and the value that is writing by that processor is, say for example, x is equal to 100, okay, and at the same time if some another processor wants to read something, so definitely if write operation is performed and then read will come, definitely that second processor will fetch the recently updated value of x instead of the previous value. So definitely dependency would be there, synchronization should be there in this case, okay. But the application of distributed system and application of parallel system is totally different. It is designed to achieve some specific task or for some specific application, and distributed system was designed for some specific application. So in this case, what are the first of all application and how it works actually? So parallel system is basically working like this. Suppose if any large task we have, so that task will be divided into a large task will be divided into small subtasks, and each task would be allocated to each processor in the system, and these tasks would be executed by this number of processors simultaneously. So definitely the performance would be improved in this case. Performance would be very high as compared to distributed system, because in this case the task is executed concurrently by each processor in the system. There is no concept of replication in this case. Means what? The whole task is divided. Fragmentation is come into the picture. Whole task is divided into small, we can say subtask, and each subtask would be given to each processor for execution. So definitely the performance would be very high, but at the same time the scalability is poor, because all the processors are dependent on one global memory area, and because of the bandwidth of the memory, you can insert, or you can say you can add limited number of CPUs or processors in this particular system. Otherwise, if you are increasing number of processors gradually without considering the concept of shared memory, or you say common memory area, definitely your signal would be noisy at a particular moment. Fine. So definitely you can insert limited number of CPUs or nodes in this type of system. Means what? Scalability is poor as compared to distributed system. Fine. But what are the advantages and where it is applicable actually. So parallel system is applicable, when we are talking about, supercomputers. So supercomputers are designed in this particular way. Means a single system will have multiple processors, and each processor share one common memory area. So definitely you can, and you know very well, supercomputers are very fast in terms of execution. So such type of systems, advantage of such type of system is what? The performance is very fast, or say it is very good as compared to distributed system. Fine, but the drawback is what? Scalability. It suffers from scalability issue. Okay, so this is all about parallel system. Now next one is real-time operating system. So what is real-time operating system? So in this type of system, the time constraints is the key parameter. In real-time operating system, the time constraints is the key parameter. What it means? It means what? Such type of systems are strictly time bounded. Means it controls autonomous systems such as, say for example, robots, satellites, air traffic control systems, etc. Means they are the applications of real-time operating system. So it means this type of operating system controls or can say manage the autonomous system. Autonomous system means what? Independent systems, such as say for example robots. In robots, we are using real-time operating system. Okay, satellite launching, we are using real-time operating system. Air traffic control, we are using real-time operating system. Or we can say traffic signals. In that case, we are using real-time operating system. So these are the various applications of real-time operating system. Means this type of operating system can be used when we have time constraints. Means what? The time is, we can say processing delay is fixed. Execution time needs to be fixed priorly. Okay, and after a fixed period of time, this event needs to be happen. If such type of strictly time bounded execution is required, in that case you can use real-time operating system. Okay, when user gives an input to the system, okay, it must process within the time limit and result is sent back. So as I told you, when any user send a request, so that request needs to be fulfilled immediately, okay, by the system, and result needs to be sent back to that initiator. Okay, so a real-time system fails if it does not give result within the time limit. So it is strictly, as I told you, it is strictly time-bounded system. Yes, you can see, in satellite launching, the execution of time is fixed priorly. Yes, time delay is fixed priorly. So after fixed interval of time, this event needs to be happen. Then after some time, this event needs to be happen. So everything is priorly finalized. Okay. So if system is fails to do so, definitely that system won't be functional properly. Okay, like say for example aircraft monitoring system, okay, or we can say satellite launching. In that case, we are using real-time operating system. And again, real-time operating system can have two types. One is hard real-time system. Means what is hard real-time system? The name implies hard real-time. It means these type of real-time operating systems are precisely, or it is a strictly time-bounded operating system. So just like what are the examples of hard real-time systems? Like as I told you, air traffic control, satellites. Okay, in that case, we are using hard real-time operating system. Okay, so it is strictly time-bounded. Okay, everything is priorly finalized, and according to that, it will be executed. Okay, and the next one is second type of real-time operating system is what? soft real-time operating system. Means again, name implies definitely the execution will be there. In this case, if users request an input, definitely that input will be processed and output will be given to that user. But execution will be performed definitely. But it is not strictly time bounded. Means what? The execution time is not finalized priorly, or you can say there are chances of delay in such type of system. Whereas in the case of hard real-time system, there is no provision of unnecessary time delay. Okay, delay we cannot afford in the case of hard real-time system, but that can be possible in the case of soft real-time operating system. For example, digital telephone, or you can say digital audio. These are the examples, or you can say applications of soft real-time operating system, in which delay can be there. Yes, but that delay not impact much on the output at the end. But in the case of hard real-time, definitely if delay happens, it will create a huge impact on the output. So this is all about real-time operating system. So in this particular session, we have understood three different types of operating system. One is distributed operating system, second one is parallel operating system, and third one is real-time operating system. So I hope it was clear to you. Thanks for watching this video. See you in the next one.